My name's Amanda Hurite.
My name's Jackson Keidel.
My name's Colleen Beyer.
And we are doing Project 2. We conducted an experiment to test the in-game simulator in the NFL Madden 2011 game. We wanted to test how different factors would affect the results in the in-game simulator. The factors we chose were penalties, injuries, and player fatigue. These factors were chosen because in a real NFL football game, these would affect the score. Presumably, having these factors would result in a lower scoring game. These factors were binary, so they were tested on two levels, either on or off. Our hypothesis was to test if the number of points scored by the New Orleans Saints would be affected by the ability to have penalties during the game, injuries during the game, or by player fatigue. The null hypothesis is that all the effects of the factors and interactions will be equal. The alternative hypothesis is that the effects of all the factors and interactions will not be equal. A response variable is a factor that measures the outcome of different levels of factors in the experiment. The response variable we chose was to record the number of points the New Orleans Saints scored in a game. We thought this would be the most effective way to measure the effects in the in-game simulator. A control variable is a factor that is held constant in order to allow for the response variable to only be affected by the factors being tested. In the game, there are many factors that we needed to hold constant so that the response variable was only affected by the variables being tested. Each game we ran, the Saints played the Minnesota Vikings so that we could reduce the variation caused by different teammates or teams. Some of the other variables we controlled were quarter length, skill level, coach mode, which allows the user to decide which plays the team runs, scenarios, amounts of yards for offense penalties, amounts of yards for defense penalties, AI for offense, AI for defense, and AI for special teams. Using design of experiments, we designed a 2 to the third factorial design. There are 3 factors evaluated, each with a high-low, which means there was a total of 8 response combinations, and we used Minitab to randomize our design. The experiment was run 3 times to ensure that all bias was eliminated, and because running it more than once would let us know if the outcome of the game had changed, even if the factors did not. We wanted to get a good average of effects, however, running it more than 3 times would have been too time-consuming. To run the experiment, we used 2011 NFL Madden for the Wii. We set all of our nuisance variables constant so that they would not affect the data. Using the run order we obtained from Minitab, we ran the experiment, changing which factors were turned off and on. In the following video, you can see how we ran our experiment.
Each time we ran the experiment, we recorded the final score for the New Orleans Saints. We put the data in a mini-tab and then ran our initial analysis. Factor A was penalties, Factor B was injuries, and Factor C was player fatigue. We ran our analysis by going to Factorial Design under the Design of Experiment tab on the toolbar and Mini-tab. Our original model contained all the factors and the interactions between the factors. We found that only the interaction between factors A and B was significant. The p-value for the AB interaction was 0.008, which indicates that it was a significant effect. The R-squared value is how much variability can be explained by the model, and its value was 41.29% in the original model. The R-squared adjusted value was 15.60%. We decided to remove all interactions besides the AB interaction from the model, and we removed factor C because its p-value was 0.866. Our final model just included A, B, and the AB interaction. Our final model was y equals 24.917 plus 1.417 times A minus 0.750 times B minus 4.417 times AB. The p-value for the AB interaction was 0.005, so it was significant. The R-squared value dropped to 37.90%, but the R-squared adjusted value rose to 24.96%.
We used Minitab to construct an interaction plot and a cube plot. The interaction plot shows the change in means of factor A and B at different levels and how the two factors interact with each other over these changes in means. The interaction plot shows that penalties and injuries interacted at a mean of about 25. The cube plot shows the averages of means of A and B at high and low levels. It shows that when both penalties and injuries are turned off, the mean was about 20. When penalties was turned off and injuries was turned on, the mean was about 27. When penalties was turned on and injuries was turned off, the mean was about 31. When both penalties and injuries were turned on, the mean was about 21. There is a significant interaction between effects A and B. When penalties and injuries are allowed in the game, there is a significant effect on the number of points the Saints score. There is a negative effect, meaning the Saints will score less points when these factors are turned on versus when these factors are turned off. Since there was a significant interaction between factors A and B, we can reject the null hypothesis. The p-value was 0.005, which is less than our test statistic 0.05. We would want to run this experiment again. The R-squared value is too small to rely on the model. More replications would be helpful in noticing effects. A two-factor design might have showed more effects than our three-factor design.